Alright folks, well, we looked at some of the primitive data types last time around, so let's take a look at strings here. So this is where we kind of make typically a transition from the primitive types to some of the more composite types. But we'll take a look at how strings might be implemented in a variety of different languages. So again, strings are obviously one of the most widely used, widely supported data types, simply because we're constantly interacting with the user in terms of text. Right? And so you've got to have a way to let the user type stuff in, and you've got to have a way to print stuff out. So the string types might be explicitly provided as part of the language. They might get provided as a library, or they might be provided through kind of implicit support using character arrays or something like that. But there's always some way to deal with text in a language. So for the most part, strings get treated as either arrays or vectors or sequences or lists of characters. That might be hidden from the developers, but behind the scenes that's almost always the case. So you've got this primitive data type, whatever your character type is, again, whether this is ASCII based or whether it's Unicode based, you've got this primitive data type and you've got some collection of them, and your string is this sequence of characters. There are a few things that we have to think about if we're going to deal with strings. Do we have fixed size strings or dynamic size strings? Now obviously if you've got a constant, it's no big deal. You set aside enough characters to hold whatever's in the constant, no problem. But if you're dealing with a variable, if you're doing something like letting the user enter a string and you're storing it in a variable somehow, then you don't know how much text they're going to provide. Or if you're storing a bunch of text, storing a string in a variable, and later on you want to append something to it, you're adding more stuff to the end of it, you're changing the length of the string stored in this variable. How is that going to work from an implementation point of view? How is your compiler turning that into code that's actually going to work correctly at runtime, where the string associated with some variable is going to potentially grow and shrink over time? Am I growing and shrinking the storage space for that variable over time? So when we're going through and working with a string, do we fix the size of it in advance and then simply stick with that, or do we provide some kind of a resize mechanism during execution? Right? C takes that kind of static approach where usually what we'll say is, well, we'll actually implement things as a character array, and it's got some fixed size, and however much of it we're using right now, we'll stick a special termination character in at the end to say, okay, well, I've allocated 500 characters in this array, but right now we're only using the first 12, so you've got your 12 characters and then this null terminator to indicate, okay, that's the end of the part that we're actually using at the moment. An alternative is to go through and say, well, what we'll do is to actually have the first byte of the string store the string size that's actually in use. So you store a size at the beginning of it, and then you've got the actual characters of interest. So either way, we've got an issue if we need to change the size of this thing later, if we need to exceed the allocated length later. So again, the C convention is to use this sort of null terminated idea, and this is widely supported by the different string library routines in C. You've got this special character, the null character, used just to mark the end of the part that's actually in use. And the string manipulation routines provided in libraries and written by most developers don't care how big the actual array is. They just work their way through it until eventually they hit this null character and go, that's the end. So it does mean that you can't just look up the size of a character array, the size of a string, because you have to go through and say, okay, well, where's the actual end of it? I know I've got 500 characters or whatever allocated for the array itself, but where's the end of the useful part right now, the part that we've actually got something real stored in? It also means that if you do things like forget to insert the null at the correct position, then the next time a routine comes along that goes through and uses your character array, it goes trundling off happily through memory looking for the null that isn't there. Again, the other possibility is to go through and store the current length as a byte at the beginning of a string. So you say, okay, well, I've got 500 characters allocated for my array, and I'll have one byte at the front that says, right now I'm using the first 17 or the first 84 or whatever it might be. So this allows you to very effectively look up where the end of something is. It just means that you have to remember to update that whenever you change the current content of the array. So, and it does also mean that you're storing that one extra size as part of the array. So this is a pretty common approach for sort of string classes in object-oriented languages. You go through and say, okay, well, if I'm storing a bunch of information anyways, I'll have the actual character array, and I'll have an int or whatever it is someplace that tells me how much of it is currently in use. And we'll come back and deal specifically with some of the resizing issues later. So pretty typical collection of string operations, right? I want to be able to copy one string to another. I want to be able to insert content into the string. I want to be able to look at a specific character somewhere within the string by position. Maybe I want to be able to overwrite a portion of the array by position. I want to be able to search for a character or search for a pattern, right? These are all pretty common. Be able to delete or replace a pattern, maybe a pattern of a different size even. I want to be able to look up how long the string is. I want to be able to convert from upper to lowercase or vice versa. I want to be able to do things like trim off any white space on the ends or at the beginning, or take care of how things are aligned within it. So there's a whole slew of different common string operations, just based typically on how we usually wind up interacting with the user, right? We want to be able to display text in a meaningful way for the context that it's in, which usually winds up meaning we have to be able to do things like search for something and replace it, or extract a useful piece, or trim something, or add something. So pretty typical suite of operations. Now, the kind of array-sized approach to, or array-based approach to storing strings works well as long as we have a fixed size for the individual characters. Right? If we know that a character is 1 byte or 2 bytes or 4 bytes or whatever it is, if I'm using Unicode and I decide I'm going to use an 8-byte pattern for my Unicode characters, then we can go through and pretty easily use an array and just say, okay, well, it's an array of this many elements, each of this size. But for kind of true Unicode, if you like, the characters can be of arbitrarily long size. There can be, Unicode allows for continuation bytes saying, okay, there's more of this character coming in the next byte. There's more of this character coming in the next byte. So if I'm actually just storing the individual bytes for each of the individual characters, then I'm not truly looking at, I can't predict. Even if I know if I've got 60 characters, I don't know where character 59 starts and ends, because I don't know how many bytes long each individual character is. The way I would figure it out is to go through and start reading the bytes for it and say, oh, no, this one says there's one more byte for this character, I'll go read it. Oh, it says there's one more byte for this character, I'll go read it. Oh, no, there's no more bytes for this character. And then we'll start on the next character. So you wind up having to, again, kind of search your way through the string to figure out where each character begins and ends. And so this is why it's very common in languages to go through and say, well, you know what? I don't want to have to search my string every time I'm looking for the ith character. So all I'm going to do is pick some reasonable bound and say that I'm going to assume that they're all 8 bytes long. And, the ones that only take up 1 byte, well, we'll just put them in, the first or the last byte of that 8-byte set. But I'm just going to assume that they're all this size. If they don't fit in that, too bad. And if they're smaller than that, well, I've got some wasted space. But it means that at least my operations to look up individual characters by position are going to be efficient. So it is quite a common approach to making an operation more efficient at the expense of some storage cost and some limitations on what I can actually store. So there are things to think about in terms of the operations themselves and the storage mechanism we use for them. Now, when we get to talking about arrays, we'll start talking about what happens if I need to dynamically resize something. If I want to change the length of the string, I want to insert something in the middle of it, or I want to insert something at the end of it. Or if I suddenly chop the string from being, 5 million bytes to 3 bytes, can I do something to reclaim that storage? So we'll take a look at that when we look at resizing arrays in one of our upcoming segments. All right, that's where we will leave that for now.